So good afternoon, everyone. Thank you for joining us today. It's a great pleasure to have Dr. Shamima Sikder today. Dr. Shamima is an MD, so it's different than what we usually have speaker coming from the AI domain. So it's great to see what people who are at the multidisciplinary, who's not necessarily an AI expert, but at the same time managed to do a lot when it comes to AI in her domain. So Dr. Shamima is an MD. MD is the L. Douglas Lee and Barbara Levison Lee Associate Professor of Ophthalmology at the Wilmer Eye Institute at Johns Hopkins University School of Medicine. She specializes in cornea and complex cataract surgery and is also the director of the Center of Excellence of Ophthalmic Surgical Education and Training at the Johns Hopkins Hospital. She holds a faculty appointment at the Malone Center for Engineering in Healthcare at Johns Hopkins. She has a particular interest in surgical education and training, and through NIH support is working on technologies that could be implemented at the international level to improve the standards of ophthalmic surgical care. Dr. Shamima received her MD degree from the University of Arizona after obtaining bachelor's degree in chemical engineering. So that's an interesting one. That's my first question to her. You were chemical engineering now, then MD, then now AI, and it's a very interesting journey. You might want to tell us a little bit more about it. She completed her residency at the Wilmer Eye Institute and fellowship in cornea and refractive disease at the Moran Eye Institute in Utah, where she received the Class Dolman Fellow of the Year award, recognizing the most distinguished cornea fellow in the nation. She has returned later to Wilmer in 2011 and served as Assistant Chief of Service and an Associate Director of Ocular Trauma. She was the inaugural Medical Director of the Wilmer Eye Institute in Stada in 2014, where she continues to care for patients in the National Capital Region. It's giving me great pleasure to welcome you today, and we look forward to hearing your presentation. Thank you.
Thank you so much for that warm welcome. I'm delighted to be here this afternoon with all of you. And I thank those of you who are here in person and those who are online. I do appreciate you joining us today. So I just want to make sure that you can see the content there. And can you hear me all right? Perfect. All right, well, I'm going to set a timer because I know there's a lecture in this room shortly thereafter, and I want to be respectful of time. So as Dr. Yop mentioned, maybe a little bit different than what you're used to, but hopefully over the next few minutes, we'll have a chance to chat about applications of AI within clinical medicine. And so indeed, I am not an AI expert, so feel free to save some of the tough questions till the very end. But I do hope we have an engaging discussion and you get to see some of the exciting work that we're doing at Hopkins, because ultimately, what you're doing here with your training is really going to change the world. But I think the key is figuring out how we partner up so that we can do it together. All right, so my title is Artificial Intelligence-Driven Surgical Skill Optimization, and I put the artificial in parentheses because the truth is we have to figure out intelligence-driven design first before we can make it fully artificial. So I'll share our journey together. Just to disclose there, I will be discussing some technologies that have intellectual property protection filed by Hopkins. All right, so let's start just by getting a sense of what we're dealing with when we talk about global surgical burden. So back in 2012, there are over 300 major surgical procedures performed in the world. And if we look specifically at what are the most common, at the top includes, oops-a-daisy, cataracts. So cataracts are a clouding of the lens inside the eye, and it's actually the second most common cause for blindness. And there are approximately 60 million people who have cataracts and are blind because of it. And in the US, there are approximately 4 million surgeries produced each year, whereas in the rest of the world, there are about 20 million surgical cases. But clearly, the global burden is high. And so the question is, if we really want to have an impact and help alleviate global blindness, how can we help this mission of improving surgery? So we know that across the board, more countries around the world are focusing on increasing their cataract surgery volumes. But in order to sort of look at the bigger mission, we have to figure out how can we increase competence of those who are practicing surgery. So that means those who are training for surgery and those who are actually out in the real world performing surgery. So when we think about competence, there are sort of multiple ways to approach it. One is the fact that there's a cognitive component to think about what needs to be done. And then, of course, the other is making sure that the hands can actually do it, right? So that the hands and mind are on par. So those are two really important things. You'd hate to go to a surgeon who didn't have either of those particular skills. The third, sort of more nebulous, the other competency, someone who has good manners and makes you feel reassured and builds a rapport, has experience that can really qualify them to be a good surgeon. But that all sort of comes together. Now, as you can imagine, some of that is technical and some of it is not. So how do we create more of a science when it comes to being able to improve surgical care? So what I offer is that if surgical care is not optimized, it has an immediate consequence on patient care, right? So unfortunately, we may all have a loved one or a friend of the family who has undergone surgery and not had a good experience. And that sometimes may simply be part of the risks of surgery, and we know that nothing is guaranteed. However, competency is a key component, and we always want to make sure that the healthcare system is optimized to promote competency. So as far as the scale for competency, it's something that evolves over time. And so the Dreyfus model of skill acquisition, it's sort of, you need to know what you don't know and then figure out what you don't know and then actually know it. So in order to train competent surgeons, we need to be able to credential them and have a standardization in training. So here is an example of some of my colleagues and trainees at the Wilmer Eye Institute in our surgical training center. And the truth is, when we think, for example, with cataract surgery, there is indeed a very specific route to training, and there are specific outcome measures. For example, trainees are expected to have 86 cataract surgeries completed as a primary surgeon before they graduate. But the reality is, this is just one small component. In the career of a surgeon, you're trained for a little bit, and then you have to go out into the real world and actually start operating on patients. And the truth is, once you're out in the real world, the level of supervision goes down dramatically. And so nothing stays the same forever. And if some new techniques come out and you're in practice by yourself, you're going to rely on YouTube videos and surgical conferences and unfortunately trial and error to make sure that you become competent. And that just can't be the way that we practice medicine. So why are we looking at cataract surgery? So we published in a few different domains. Specifically, we know that surgery is a learning experience. So if you're a new surgeon and you're learning, you're going to have higher complication rates, and those rates go down as you become more experienced. What's interesting is surgeons have to learn from other surgeons, and these surgeon teachers actually, their experiences will reflect on the experiences of the trainees. So we published a paper in 2015 showing that if you're a young and enthusiastic surgical attending, your complication rates may be a bit higher than someone who's a little bit more experienced. And so there are multiple levels of competency that need to be addressed. So first, I want to just take a couple of minutes to talk a little bit about human-driven surgical skill optimization, because if we can understand the problem as it stands now, then we can figure out how to optimize it further. And so this is sort of what happens in the surgical domain. You have knowledge, you operate, and hopefully someone who's very perceptive and a good educator is paying attention to you as you operate and giving you feedback. You're doing this well, you're not doing this well, this needs to improve by this method. We now have capacity for videos, and this is where it gets really interesting, because ophthalmologists, we operate at a microscope. And so if we have the optics to be able to look at our field, we now have very easy ways to capture video of the surgical field. And additionally, there are newer methodologies using simulation, whether it's virtual reality simulation. There's an example here of the IC simulator, or wet lab simulation, where basically you're practicing on either animal eyes or plastic eyes, but to get some experience before you're operating on human patients. And all of that comes together to sort of give you the green light to go out into the world and operate on human beings. So how can we optimize this? Well, the reality is it's very inefficient now. So if I want to give formalized feedback to some of my residents, I have to log on to a system, And as you know, the more clicks that you have to do something, the less likely you want to do it. And so imagine all these arrows just to get the process started, to be able to get to a form. And what's important here is this is a standardized rubric that basically you can rate the surgeons on a scale from 1 to 5, 5 being the highest. And basically go through the different steps of cataract surgery to offer your feedback and have that recorded. And then that can all be processed in this very user unfriendly database. And so you can imagine this feels like paperwork that's not really helping, right? But it's better than what we had when I was a trainee, which was just some words that you may or may not remember under the stress of the operating room. So we can do better. And the idea is that how can we use artificial intelligence to now drive this optimization of skill? So before I get too deep into it, I do want to acknowledge that it's a team effort. So while I am the clinician who has this engineering background, which makes it fun for me to spend time at the School of Engineering and talk nerdy to my colleagues, it's really the team approach that has really led the work forward. And so a number of my colleagues from the Malone Center and the Department of Computer Engineering, as well as our partner in design, Cindy, we've all come together to try and address how we can optimize this idea of using technology to improve surgical skill. So this is probably where my chemical engineering background comes out. I love processes. So if you can give me a process and I can draw some boxes and arrows, I'm pretty happy. And so when we think about surgery, there are basically ways that we can think about the input of the surgical performance, think about how the data that we are gathering is being evaluated, and then figure out the output. So in an ideal world, you will take these different components that are available to you, figure out what is actually helpful to you, the surgeon, and use that information to improve your surgical skill so that your patients do better. And if we were to plot this, and of course it's a lot of small detail that you don't necessarily have to go through specifically, but the idea is different things have different levels of usefulness, right? And we know from individual learners and adult learners, not everyone learns the same way. So we have to figure out what are the different metrics that are valuable for a surgeon, but also more importantly, how can we optimize that whole process so that each learner is able to get the information that they need. So we thought to ourselves, okay, if we're going to really try and make a science out of this, what is considered educational art of surgical training, how do we change the paradigm? And so the idea is that we want to use artificial intelligence to assist in feedback. Namely, we want to take surgical videos, which are so readily available and often discarded. And basically, if we imagine that cataract surgery is a story, we want to be able to take that story and chop it up into pieces or chop it up into specific chapters, so that we can now start to have a discussion where we're all talking about the same thing and looking at the same thing. And if we can then, for example, break apart parts of that story, then we can analyze the specific behavior or storyline, if you will. And with that assessment of performance, work towards allowing the surgeon to have specific feedback on how to improve. And the idea is that if we imagine that any technical skill has a learning curve, in order to receive or achieve that master status, you need to have specific feedback that allows you to optimize your skill. So here's another way of looking at it a little bit more technically. So if we have the idea of sort of leveraging AI as an assistant and asking, how did I do? Well, what we would hope is that the surgical video can get chopped into specific phases. And by chaptering these phases, we can then specifically sort out which are the key elements that need to be further addressed. And by looking at those specific chapters, we can then assign a score so that we get different levels of feedback. And you can imagine this is much like inspecting a car, right? If you're going to rent a car at the airport, you just want to make sure it turns on and the gas tank is full. If you're going to invest in a historic vehicle, you're going to make sure that every doorknob and paint chip is in place. So not every inspection or every report needs to have the same level of detail. And part of it is understanding who needs what. So a beginning surgeon may need to focus on the preliminary steps of surgery, whereas a more experienced surgeon may need to optimize more nuanced points. And so the idea is being able to offer feedback so that there's specific value in what's being told to the surgeon and how that skill can improve. So how do we get started? So hopefully this will resonate a little bit with all of you. So basically we said, okay, we have these videos and we want to do something meaningful with them. And what can we do? So step one, why don't we ask Shamima to look at the videos? Well, I love looking at videos. The problem is it's a lot of videos. It's a lot of videos and there's not a lot of time necessarily in the day. And so the idea is how can we then leverage some of the resources we have available? And we started with a crowd. And believe it or not, we asked, can a crowd annotate instrument labels on these surgical videos? And believe it or not, crowds are pretty clever. And so what we did in 2018 is we published a paper basically showing that can we ask the crowd to reliably annotate information on surgical instruments, namely what the instrument is and where they are, from a surgical video data set. And so the answer is yes. And so here's an example of some of the instruments that we looked at in the different parts of the surgery. And basically we allowed the folks within the crowd to be able to learn what these different instruments are and offer them the opportunity to actually annotate the different boundaries of the instruments. We used Amazon Turk as our platform, and we actually ran the study twice with 2 different groups to make sure that we weren't just getting a particularly good group of people who were surgically inclined. And by looking at the effectiveness of this method, we found that there was pretty good inter-rater reliability and remarkably high accuracy of the crowd to be able to annotate in compared to the expert. So this initial paper was pretty encouraging that yes, crowdsourcing can be used to identify these instruments within surgical videos. So now we can get a crowd to do some of the work. That's good. So I can sleep a little more. I have a set of twins at home, so they were probably happy that I'm a little bit more available. But the question is, what shall we do next? And so our next step was to focus on how we can efficiently use ratings to assess skill. So remember when I showed you there was that video and we chopped it up and we're going to look at only some of the chapters? Well, which are some of the chapters that we should look at? Because ultimately, we need to make sure that the amount of work that we're putting in is actually worth it. So one of my favorite expressions is the juice worth the squeeze? And we don't need to squeeze the entire lemon to get every single drop. We just need to get enough to move forward. And so what we did is basically looked at objective ratings of all of the chapters and try to correlate and see which specific chapters maybe have the highest yield when evaluating the overall skill. So if we're caring about, how good is the surgeon, what specific steps can we look at? And these are examples of some of the steps within cataract surgery to try and understand how good the global skill is. So what we found is time a valid measure of skill? So this was sort of an initial question. People sort of asked the question, how long did the surgery take? So cataract surgery, the most commonly performed surgery in the US, takes on average probably about 15 minutes. If I'm particularly, speedy that day, maybe I can do a case in 8 minutes. But to be honest, what's the rush? I take my time and I just go at 12. But if I'm a new surgeon and it takes me an hour, that's not ideal, especially if that patient is your grandmother on the table waiting an hour for her surgery to finish. Well, one could make the argument at the end of the day, if a patient who takes 15 minutes and a patient who takes an hour are both doing well, was it so bad that it took an hour? I would make the argument that if I was the one laying there for an hour, probably I would prefer to be done in 15 minutes. But the key is we can't always correlate time to say faster is better, because honestly, I would much rather have a surgeon who is diligent and careful and takes 14 minutes than someone who's rushing through and seems to be thinking about the next patient and trying to push that surgery into 8 minutes. And so what we tried to do is really evaluate skill and time. And what we found is that if we try to look at how we group the surgeons, and this is a bit busy, but basically to show that if we correlate time and skill, there's actually no correlation. So it doesn't matter. You could be a surgeon dealing with a really complex case that's just taking a few extra minutes, or you could be a slower surgeon that's dealing with a more straightforward case that's still taking a few minutes, and both may take a few minutes extra, but that doesn't necessarily mean that one is better than the other. We still need to do a little bit of subset analysis, because if we were to, for example, rate the cases as far as complexity, then chances are we would find that a more experienced surgeon is able to do more complex maneuvers in a shorter period of time. And that's our hypothesis. But overall, just asking, is the time correlated to skill? The answer is no. So we know now what steps to look at. We know that we can get crowds to annotate the instruments, but how can we maybe make this process more efficient? Specifically, can we automate phase detection? And the idea behind this is that if we can actually find ways to leverage technology to get the steps to be chaptered, then that really helps us in our process to automate the whole process in itself. So in 2019, what we did is we looked at 100 videos where we tried to assess, can we determine the phase of the video using machine learning and deep learning methods? And so we had these 100 videos that were performed by faculty and trainees, so surgeons of different experience levels. And we had basically 10 chapters that we had defined and 14 instruments that were basically identified over the course of the surgery. And so what we did is we looked at these 5 different algorithms, and so you can see them there, an SVM, an RNN, CNN, and then a combination thereof. And basically what we tried to do with a 5-fold cross-validation effort is to try and figure out, can we tease together a protocol that would help us in identifying these phases of cataract surgery? So if we look at the unweighted accuracy for these 5 algorithms, overall we did pretty well. So they range between 0.91 and 0.96. And so the AUC did range between 0.7 to 0.77. But the important thing to note is that it is possible. And so with this in mind, what we said is that we want to be able to use instruments to help figure out the phase. And so basically whatever tricks we can use to be able to take that video and chapter it is going to help us in our overall process to take the videos that we have and be able to assess the skill. And so in this paper, we demonstrated that the time series model of instruments may be used to help automate the identification of the phase in cataract surgery, effectively making our workflow more efficient. So clearly we're making progress. We can get the crowd to annotate, we can get the machine to identify the correct phase of surgery. But you see how it's like a slow moving train. We're like boarding, we're getting our tickets, we're on the platform, but what we really want to know is how good is the surgeon, right? And so we're making progress. It takes a little time to gather full steam, but we want to be able to assess performance. And so in 2019, the later half of the year, we looked at this paper, which helped us develop and validate deep learning techniques for technical skill assessment. So now this is where we're getting to the exciting part. How well is the surgeon doing? And so in this paper, we again looked at 100 videos. And this time we focused only on capsulorhexis, which is one specific step, which is a critical step in cataract surgery. And what we did is we used a validated rubric, which again is that 1 to 5 scale rubric that I had shown you. And we define an expert as someone who scores, for example, there are 2 specific steps within this step that are being evaluated. So if you score a 5 and a 5, you're an expert. If you score a 4 and a 5 or a 5 and a 4, you're an expert. But as soon as any one of those variables drops down to a 3 or a 2, and any combination thereof, we'll label you as novice. And the idea is that maybe instead of having everyone have a really granular feedback, we just kind of need to know, are you a master? Are you not a master? And that sort of allows for competency to be addressed. So what we did after annotating our data set is we basically modeled instrument trajectories, and we used optical flow using a temporal convolution neural network to predict the skill class and to predict a score. Excuse me. Okay, so we evaluated our algorithms again in a 5-fold cross-validation, and we computed the accuracy and the area under the curve. And so if we look at this in table form, what we can see is that the AUC was 0.848 for instrument tip velocity methods and only 0.634 for optical flow fields. So we see a little variation in the data, but we found that there is accuracy there depending on the models that we use. So that paper, we concluded that deep neural networks can help model surgical skill in the specific step called capsulorhexis using optical flow fields extracted from the crowdsourced tool location. So building upon the earlier work that we did. Okay, so we're making progress, right? So we can use the crowd, we can get the machine to identify the phase, we can get the machine to now assess the performance of that specific chapter. So where do we go from here? So ideally what we want to do is focus on automating this process. So what does that mean? That means that we want to be able to label directly from the video. So we want to skip annotation. Annotation, human-based, is time-consuming. Sure, crowd-based is an alternative means to do it, but it still takes time. So ideally, we want to be able to automate the labeling of the instrument. This is sort of a roundabout solution. Obviously, what we really want is just to be able to automate the chapter, right? So we know exactly what stage of the surgery we're dealing with. And if we can automate the chaptering, you can imagine that there's a lot of data we can then shake out of that. For example, how long is it taking for that step? What is the complexity of that step? What is the skill of the person who's performing that step? And then we have some more data that I can show you in a moment, but basically, if we are able to annotate where the instrument tips are, and we're looking at the instrument velocities, then can we have a more specific feedback where within a step, we can say, okay, for example, one step where you're making a circular tear, if we divide it into quadrants, this specific quadrant, you're struggling, but the other three, you're doing fine. So now it's a matter of giving feedback of, you were a novice, work on it, versus you were a novice because in this specific quadrant, you're struggling every single time. Here are now some examples of how you could improve your skill by showing you what that better skill looks like. And that again is leveraging the fact that different people learn in different ways. And so sometimes being able to have, for example, a video library may be more effective. Obviously, we want to work on increasing the robustness of our automated analysis. To me, and you all can educate me even further, but AI really feels like a living, breathing being. And when we have these algorithms and we wanted to do something, our data sets change, our mechanisms of sort of level of detail that we're looking at change. And ultimately, there's also concern that there's bias. There's bias everywhere, right? There's bias in how we're training the data set. There's bias in the scoring that goes into the training data set. And the last thing we want to do is propagate that bias. And so there's clearly a lot of work that still needs to be done. And then one of the other interesting projects that we're looking at is how can we maybe create a narrative feedback? So as a surgical educator, every year we have a new batch of residents who come and they're learning and they're starting from the same beginning. And now, I can tell on the way that someone is going to approach the eye with their instrument, whether they're going to be able to even get it inside the eye. And sometimes I think to myself, okay, well, I'm going to let them struggle for a moment because maybe then they'll learn it better. Or I'll just tell them, your elbow's too high. You need to drop it down and lower your approach because you're not going to be able to make it inside the eye. And the truth is, different people learn in different ways. And so sometimes I end up repeating myself over and over and over again. And that's one of the reasons why I think it's so ideal to be able to find a way to help scale that feedback, because common things being common, everyone doesn't necessarily need to struggle the same amount for different themes that are repeated over and over again. And so one of the projects that we're working on is creating this narrative feedback where the things that surgical educators will often say, we can sort of automate the process. So if we can now chapter the video, we can track the instrument velocities, we can look at the way that the tooltips are moving, and we can elicit a specific sequence of events that's going to create the same dialogue. Well, why not automate that process and allow the learner to experience that in a less stressful environment when they're learning to operate also by thinking about what they're doing outside the operating room. And that has some interesting applications with natural language processing. And so we're working with some of our faculty there. So what is in the pipeline? So one of the projects that we're looking at is using spatial temporal attention models for video-based assessment of the skill. And the hypothesis that we're testing is that if we can offer explicit supervision of spatial attention learned data from the image, we can improve algorithm performance in both internal and external validation. So this project is being done by one of our current master's students who actually will be staying on at Hopkins to do a PhD. And so he hasn't quite published yet, but I just wanted to share a little bit of sort of the overall workflow. This is the point of the presentation where I'm sort of in recruitment mode. So basically, we are privileged to work with a really great group of people. So the faculty members that we work with on the technical side are all really brilliant, of course, as they are here. But we have the advantage of the clinical data sets within Hopkins Hospital that we want to leverage. And so our research meetings, I think, are pretty fun because we all Zoom in, even though the pandemic is easing up and hopefully we'll be in person together more often soon. But we're able to sort of I share my perspective on a clinical sort of theme, and then my colleagues are able to share the technical feedback. And then we work together, and it's good because whenever there are data sets and sort of analyses that are being shared, I like to just take pause and take a step back and say, what is the clinical application here? Because sometimes I think the challenge with engineers and clinicians working together is that if there's not open communication, both parties can sort of run up into different directions, and then we're not meeting at the right place. So this is just a little hint of some of the things that who our grad student is working on. And so what we're looking at initially is that if we augment the network with a supervision of spatial attention, there will be improved specificity of the predictions in both internal cross validation. And so we're working on a MICI submission now. So hopefully that will be out at some point and we can talk about the details a little bit more. All right, so now I will put on sort of the other hat, which is the practical hat, right? So it's nice to be able to talk about the theoretical advancement of things, but at the end of the day, what we develop is only as important as what we can deploy. And so for the last several years, I've been working with Hopkins Tech Ventures, which is our commercialization front at Hopkins, to try and figure out if we can really create something that has meaningful use for surgeons across the career spectrum, what would that look like? And so we were very lucky to receive a Microsoft Accelerator grant to help fund some of the work to create something that we really hope will be usable. And so what I'll do in my last couple of minutes here is just walk you through this platform that we've created. So basically it allows for specific user profiles to be created. And the idea is that this, for example, would be where novice surgeons can upload their videos. And first and foremost, it'll act as an organized repository of surgical videos, which is already lacking because now my residents have random things on USB drives in their bag. And the idea is if we can organize the videos, then we can streamline the data, not only as it's being collected, but also offer feedback of various levels. So here, for example, as we're watching it, I may record an audio note that's synced with what's happening on the surgical field. And often this is easier than writing things out. And more importantly, for the learner, it's easier to just listen to hearing someone say what's going on. And then the idea is that this will sort of act as the gateway to allow for objective metrics to be measured and then displayed. So at a minimum, we can start with what has already been published. So the validation rubrics that are out there can be completed, again, mirroring that expert novice classification that I described, sort of the 4-5 or 3-4-5 scale. But you can imagine, based on the learner, we can then start developing deeper levels of feedback. So really allowing for that granular assessment where we're talking about specific movement and specific skill, or just acting as a repository for example, a surgeon who's in practice, they need to prove that they can still operate. And they simply just need to have a credentialing checkbox checked off saying that, yep, your surgical skill continues to meet the standard, and that's it. So you can imagine that something like this will have application, excuse me, across the career spectrum. Obviously, we want to start with our surgical trainees because they are the most eager for feedback. Believe it or not, surgeons have a pretty healthy self-esteem and often don't think that they need to improve further, but at the end, we're all perfectionists trying to improve our skill as much as possible. As I mentioned, we are now starting to look at bias in surgical training, specifically looking at how does bias affect our training data set? So can we quantify, for example, implicit bias? So if the rater feels, oh, I'm reviewing the video of a female surgeon versus a male surgeon, or from a specific institution versus another institution, can we quantify what that bias is? You may make the counter argument, okay, so what? You can quantify there's bias. That's the beauty of video. If you just show a video, it's a hand and an eye, and you don't know who that hand is attached to. And that's true, but ultimately our training data sets do have sometimes metadata that can share some information, and we want to be able to understand how we can neutralize it so that the training data sets really are optimized. Now, I made mention briefly about natural language processing for surgical feedback. This, I think, is pretty interesting. I mean, you can imagine the application, right? That one day you can have surgical video that sort of automatically tells you how to improve, but what's the next step? Well, what if you could have that robotic voice with you in the operating room and offering you feedback in real time of how to improve? So that really gets into this idea of smart microscopes and smart operating rooms and how technology can be leveraged in real time. And now that our computing skills have improved, that is going to be a reality sooner rather than later. So as I wrap up, what I'd like to leave you with here is a sketch. And so obviously we all love, I hope, as much as I do, the power of a blank piece of paper and a pen. And so this is a little scribble that I think hopefully conveys the fact that surgical skill evolves over time. And if we imagine that there's a training curve, there are three sort of things we want to do with the curve. One, we want to hasten the learning curve so that we can achieve that maximum surgical skill sooner. We want to improve that overall skill so that horizontal asymptote is leveraged in a way that is higher. And then we want to recognize that individual surgeons across institutions, across geographical locations, will have variation in their skill. And it's not just having a bad day or a good day, but having a tough case or an easy case after a tough case. There are so many variables that can affect skill. But if we can find ways to help minimize that variation so that there's more consistency, ultimately all of those efforts will work towards improving surgical care. And hopefully I've made the point that there's a lot of surgical care that needs to be done. And so hopefully by improving that, we'll make some marks. So this work cannot be done alone, clearly. There's a lot of smart people working on it. And so I just want to take a moment specifically pointing out that it's the Malone Center who has really helped run the technical component of a lot of the work that we're doing. And these are our many students who, in the middle column, who've made it through our lab and are out in the real world doing important things. And then my colleagues within the Wilmer Eye Institute, and of course our funding sources. And with that, I'll end. That's a QR code to my LinkedIn profile in case you want to reach out that way. But hopefully, these last few minutes have helped share a little bit of a different perspective, perhaps on than what you're used to, but a little bit of an interesting discussion on how much of the important work that you're doing here today can be leveraged within a specific clinical context. So with that, I'll pause.
Thank you. Thank you very much. The floor is open for questions. And remote audience, you're also welcome to ask, please.
Thank you so much for coming and thank you so much for the talk. I have a question. So about the objective feedback that you can give. For example, you said, okay, there can be some biases or differences on the surgeon's end. What about the patient's end? Like there can be different types of cases. Like one's eye or case can be more complicated than the other. So how do you manage to give feedback objectively in that?
That is a great question. So hopefully the virtual audience could hear with your fancy system here. But when it comes to the variation within patients, there are two ways to sort of go about it. One is, what is the intraoperative variation and what impact does that have on surgical care? And second, what is the variation in clinical outcome? And I think one of the challenges we face with cataract surgery is that overall it's a successful procedure. So we were chatting earlier about what are the risks with surgery, and the risks are not zero, but they're low. For example, 1 in 10,000 chance that you could go blind from infection. So then the question becomes, well, Shamima, you're working so hard to distinguish this surgical skill from that surgical skill, but the patients do fine. And I think that that's a valid argument that the patients do fine, but the technology that we're trying to develop is not specifically going to end with just this one surgery. And so we're using cataract surgery as a test bed because it has a very set sequence of steps. And while there are sort of regional or technique variations within some of those steps, generally they are all meant to achieve the same. Your specific question about what about variation? So for example, when we're operating, the patient pupil size is important. Some patients may not dilate well and some patients may dilate really well. And if a surgeon's doing a challenging case, can we blame the surgeon for being, quote, mediocre when that pupil would have made even an experienced surgeon sweat? So that's where it sort of is important to be able to have specific metrics that reflect that patient variability. So you're absolutely right. It's not just about the surgeon, but it's the context. And I think that's one of the other reasons why this work is really important, because if you look at surgery as a sort of a one-dimensional process, this surgery was fast, this surgery was slow. That means this surgeon is good, this surgeon is bad. Often it will be academic institutions that will be penalized because we have the more challenging cases that many of those in the community don't want to do, because it's going to be a 45-minute cataract surgery, a 1-hour cataract surgery, even in the best of hands. And I think that's why the burden is upon us to make sure that whatever assessment is being done reflects the nature of the surgery itself. So that's a great question.
Another question? Great.
Thank you very much for the nice talk. It's always nice to see tools that are going into deployment. I think it's part of the nice thing of what we do with research is then seeing it realized and being used in real life. My question is more related to sort of approvals. As we know, it's usually very difficult to get stuff through AI technologies in healthcare, but this is more related to the education side of healthcare. So you're on a different side of things. But my first question is to do with how easy it is to go through the different steps of deployment when it comes to approvals, whether it's FDA approvals or, and whatnot. And then my second question is more to do with, you mentioned how nice it is to have video recordings of those surgeries, but we also talked about the wider global scale of those surgeries and where they go on. How do you think this can be then further expanded to benefit people in different countries where perhaps videos of surgeries from more high resolution cameras, from lower resolution cameras and so on, how do you think that can be further realized?
Yeah, thank you. Those are two excellent questions. So first, I'll offer a comment on deployment. So one of the things that is extraordinary about being at an institution like Hopkins is the fact that there are so many people working on so many smart things. But when you're at an institution of that large, there's also so many layers of regulation and bureaucracy and hoops to jump through. So I can definitely offer a comment on the practicality of deployment. So when we approach things from a training point of view, there's a little bit more flexibility, mainly because it's sort of under the umbrella of quality improvement and quality assurance. And many of the things that we're doing involve de-identification of patient data. And so, as you know, there are HIPAA regulations, which are very strict. And so it allows us to work within the set domains of those regulations, but offers us the ability to try some novel things. When it comes to deployment, sort of in the greater world outside the halls of academia, regulation becomes a lot more difficult. And so, for example, with the FDA, if the technology is being used as a device, and we actually have an interesting Viewpoint article out in JAMA Ophthalmology where we talk about how AI can be implemented in a clinical setting. It's one thing to create a platform like this that allows for retrospective review, because it's basically like a postmortem, right? What's done is done, but now what can you learn from it? In the future, that little sneak preview that I have in my mind where basically you're going to be operating with artificial intelligence inside, hopefully maybe not your head, but inside the operating room, That is going to require a significant amount of regulation to me, right? Because now the AI is live technology. And if the AI suggests you do something and something bad happens, who's at fault? Is it me because I helped develop the AI? Is it still the surgeon because they have the scalpel in their hand? So I think that that's a really interesting question where this ethical considerations of AI in clinical medicine, that whole discussion I think is evolving. And I think it's an important discussion to have. As far as your second question, which is an important one, as far as international implementation or global implementation, I will say that sort of what motivates me personally, I love the fact that I can help improve the quality of lives of my patients. And I operate on Wednesdays and my patients come in on Thursdays. Pre-COVID, I'd get a lot of hugs. Now I just get some happy tears, but it's really something extraordinary. And when I get to train my next generation of surgeons to do that, I find great meaningfulness in it. But this really, I feel, is a way to help improve global standards, but you're absolutely right. How, right? So often the microscopes that we operate on are $200,000 to $300,000 within the US. That's very expensive. Forget adding any technology to it. That's a really expensive microscope. We actually are looking to collaborate with a group out of Pennsylvania, where basically they are using effectively new imaging technology. I mean, the fact that now our telephones have amazing cameras far beyond whatever we imagined when we had our little actual Kodak cameras in hand, to be able to develop a basically lower budget microscope. So it would be available at a fraction of the cost. And because of the way that it's using the optics in the camera, it would be very, very easy. Very easy to, one, transmit video, assuming that you have an adequate internet source. But at a very easy second step to be able to record video, because now recording capacity has become so easy. And really, I think that will allow for proper deployment and implementation. But it's a critical step, absolutely.
Thank you very much for this very insightful presentation. I have a question regarding the annotation process.
Yes.
So given that basically the annotation is happening for a domain-specific task, right? The crowd can basically perform really well in terms of iterated agreement on examples that are relatively simple, that you can explain with clear guidelines.
Yes.
It would be interesting for the samples where there is a disagreement between the crowd to feed that into basically a database that experts can actually annotate, because these examples are the ones that will actually affect the generalizability of the model when it's deployed. So it would be interesting to feed that maybe into the platform where just an expert can annotate, and then that will be fed into the guideline that the crowd can feed off of.
Oh, that's a great point. And I think you're absolutely right. When we look back at that paper specifically at performance, there are two instruments that are very similar on side view.
Yeah.
And when you look cross-sectionally, one has a pointy tip,
Yep.
and the other one does not, but they're used in very different contexts. And so often, if in those examples, one of our students will say, "What do you think this is?" And I'd say, "Well, can you play the video? Because if I can see it being used, then I can tell you exactly what it is."
Thanks.
No, that's a great point. Thank you so much.
Any other questions? Please go ahead.
So my question, thanks for the interesting talk. So my question touches upon the previous question. So when it comes to using the systems in different regions or in different countries, do you face any challenges in the instrument labeling part? Because in different countries or regions, the instruments will be made by different manufacturers. So will this system work as one single system that fits every region? And for the results that you have presented, how about the data set? Is it from the same institute or same hospital or a variety of clinics? And finally, the system that you have presented, is it only after surgery, or can it be used real time for the chapter separation, everything?
So great questions. Right now, the system that we have can only be used after the fact. And we're working on improving the generalizability. Everything I've demonstrated thus far has been on our data set from Hopkins, which we know is a varied data set because we have experts and novices. However, now we're basically implementing a lot of our algorithms through publicly available data sets to check, how generalizable is it. But you're absolutely right, because of regional differences, there are definitely variations in technique, like using one instrument and then another versus using the second one from the beginning. And so it's interesting to see how well our algorithms are performing by shifting some of those nuances. But ultimately, that's what is critical to being able to implement this work on a larger scale.
Any other questions? So I have lots of questions. I'll leave them for later on. We'll discuss with you.
Perfect.
One question,
Yes.
and we'll finish with that if that's okay. I never visited Hopkins, but I hear a lot that amazing work happens there, especially AI in healthcare.
Yes.
Why?
I think the fact that really works for us as an institution is that we draw so many people with very varied backgrounds, that there's really a huge effort for people to talk to each other. And so our dean and our provost, they throw money at projects to help create collaboration. And I think that, they label it Discovery Award or Catalyst Award. And I think it's very apt, because basically the walls that otherwise silo us are constantly being broken. And I think that that's one of the reasons why, we have such an amazing healthcare system. That in and of itself, I think, attracts a lot of people. But the fact that people are now looking to see what they can do together is really one of the key aspects that I think makes Hopkins really special.
Fantastic. Thank you very much. With that, thank you very much.